All right, Unit 7-8 notes for review for the AP exam. So slope fields, hope you remember what those are. You get some weird equation like dy dx equals x minus y, and then they go out here and you say, well, what's going on at 1 comma 1? Well, the slope would be 0, so 1, 1. Make a little horizontal line for 0. What's going on at 2 comma 1? 2 minus 1 is 1, so you go out to 2 comma 1, and you make a 45-degree angle. For the slope, that would be positive up to the right. Let's do 1 comma 0. I would also do this. 2 comma 0 would be a little bit steeper. So what you're going to get is a slope field that you're going to have to analyze. You're not going to have to build a slope field. That would take too long. Euler's method. I've shown this before. We go x, y. We go delta x. We go dy dx. And since dy dx times delta x is more or less dy, then we multiply these two and get dy. And then we get new xy from x plus delta x and y plus delta y. I'll do a problem like that in a minute. Integral is net change. So the way I like to put this, if they say, hey, here's something in meters per second, we want meters, you're going to take an integral with respect to time. Here's something in cubic feet per meter, something stupid like that. We want to know cubic feet. You're going to take an integral with respect to meters. All right, the integral destroys the bottom. And it's just the way I think about things. It helps me get through a lot of these integral problems. Integral of acceleration equals velocity. Like I just said, hey, let's integrate that with respect to time. I should really make that an S, but you get the idea. We get meters per second. Hey, let's integrate that with respect to time. We get meters. Nice way to also remember it is to go the other way. Derivative of velocity is acceleration. Derivative of position with respect to time is velocity, so on and so on. This one you're not going to see this year, but it's good to remember. F is equal to k times x, and if you integrate both sides, you get work. That's it. There's nothing else to say. Just be aware of that. Integral in the in a plane is the area. So when we do something like this, we say, what's the integral from 0 to pi? Sine of x. We're saying, what's that area? If we said from negative pi to pi, we're saying, what's these two areas where this is negative? So that's going to be 0. Because below and above is going to cancel out. If you want to find the actual area between the curves and watch that sentence, then you do the integral of the absolute value, sine of x, pi to pi. You're not going to see that, though, this year, so you don't need to worry about it. You might. Keep an eye on it. So now we got revolution of solids, which I'll do in a little bit. But we get problems like, again, sine. Hey, what if we rotate that around the x-axis so we have all these circles? What if we have some funky shape and we have squares coming up out of that shape? How do we do that? I'll show you that in a minute. And then integral is length of smooth curve. I can't imagine you'd see this year with all they have to work on, but you never know. Calculate a problem, or the classic set up but do not solve the integral, blah, blah, blah. So let's do a couple problems and call it a day. Table at the right, give selected values, use Euler's method, blah, 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 with a step size of 1.5. That's my delta x to approximate 2, starting at negative 1. So like I said, x comma y. And they start us at -1 comma -2. I honestly have the most problem going, that's my x, that's my y. I'm not afraid to admit that. Very challenging, I find that sometimes. And my delta x, they said use step size 1.5. They really can't do anything bigger than that because you can only take 2 steps, otherwise you're working on this problem forever. What is dy dx at -1? The derivative is 2. Multiply these, you get 3, and that's going to be our delta y. Reset your xy. -1 plus 1.5 is 0.5. -2 plus 3 is 1. So that's our new starting point. No negative there. 1. Delta x is still 1.5, and 1.5 plus 0.5 is 3. No, 2. Wait, nice math. And that's what they're asking us for. Hey, what happens when you get to 2? dy dx at 0.5 is 1. Multiply 1.5, add 2.5. And there's your answer. Hey, I got it right. Very cool. Remember, I go fast because I don't like to waste video time. It takes forever to make these, takes forever to upload them. That's why there's a pause button. If you need to slow down, go right ahead. Here's the example I talked about. Hey, we need the length of a curve. What is the setup but do not solve, blah, blah, blah. All right, well, we need to do y dx. We're going to square it, but let's just get it first. Derivative of sine is cosine of square root of x. Square root of x is the same as x to the 1/2. We need the chain rule, so d dx x to the 1/2 is 1/2 x to the -1/2, which is 1 over 2 square root of x. Just changing my notation back and forth. So 1 over 2 square root of x. Done. Let's throw it in. Slow down. Slow down. Going from a to b. And they're saying everything's positive, which is nice of them. They're all from a to b, so I don't have to worry about that. Integral a to b. Root 1 plus. This thing's squared. Damn it. I hate it when it does that. So square this. We get 4x. We get cosine squared. Dx. Now we could actually do some math here if we have to, like go 4x over 4x next to the 1. Let's see if they're making us do that. 1 plus 1 over 4x, cosine squared root of x. So that would be C. Woohoo, I'm on a roll. I got another one right. Lucky day. This is a calculator problem. So I'll cheat. And, going with a unique color here. Very crazy. Base of a solid is a region of the first quadrant bounded by the axis graph of 3 to the negative x squared minus 1/3. Right. No idea what to do with that. Plug in 0. 3 to the 0 is 1 minus 1/3 is 2/3. So we're up here somewhere. Axis in the graph of, I am guessing it's going to do something like that. If I had a calculator handy, I'd figure it out. And I'm going to try that because I don't want to pause the tape. It's been half an hour blasting out my calculator. Each cross section is a rectangle at the base. So the base is here. It's the y value. And then the height is y plus 2. So we're just going to blast this out with the calculator. Area is y, 3 to the negative x squared minus 1/3 times 3 to the negative x squared minus 1/3 plus 2. Well, I should combine those. I'm letting my calculator do all this. That's the area. Integrate from 0 to where does it intersect? I don't know. Problem with respect to x. So I have to take this, blast it in a calculator, and find where it equals 0. I wonder if I can do that. By hand relatively quickly. I could probably do a log base 3. This is 3 to the negative first, log base 3. That was slick, I'm not going to lie. I'm pretty impressed with myself. negative 1, x squared equals 1. So we're looking at plus or minus 1. So this hits at 1. Oh, that was cool. Now I actually am going to put this in my calculator. I would pause this tape if I knew how to. I think I have to hit F9, but I'm in tablet mode. So math 8, nope, math 9 from 0 to 1. And this is going to be a hassle to put in. 3 to the negative x squared minus 1/3. Close parenthesis, open parenthesis, 3 to the negative x squared minus 1/3 plus 2. Close parenthesis with respect to x. Integrate. I'll be darned, I actually got it right. 0.9922. And I know that's the correct answer. Yeah. Good luck with that. First thing I would have done is graph this and make sure I know that this is the area I'm looking at. But notice it's just set up the area, slap an integral on it. A lot of people get lost on these. It's not that bad. I don't think I want to do that. All right, 1 to go. Volume of the solid that results when the area between blah, blah, blah and the line blah, blah, blah is revolved around the x-axis. E to the x starts up here at 1. 1 to 2, something like this, is revolved around the x-axis. So we draw the same thing down here. We're looking at circles like that. Kind of a funky lampshade. Integral. Well, no, I actually like to do area. Volume of the solid results. It's a circle, so pi something squared. Excuse me. And the y, this value here, is e to the x. So e to the x squared. Probably do this by hand. Yeah, it is a hand problem. It's number 8. From 1 to 2 with respect to x. So that's e to the 2x, x times 2, integral 1 to 2 pi x. I believe we're going to get e to the 2x over 2, if I'm not mistaken. Pi comes along for the ride. 1 to 2. 3 e to the x, e to the x times 2. 2's cancel. Yes, I did it right. Plug in 2 pi over 2. E to the 4 minus e squared. Neat. Hey, I got another one right. Wow, today's not a lucky day, I'll tell you what. Should go and play the lottery. All right, pull it down and replay it if you need to. There's a lot there. I would expect to see some sort of problem in that because it's a high-level calculus problem. They want to see if you're smart enough to do it. Good luck.